Hello everyone, welcome to the Squirrel GameDev, and on the today's stream we're going to take a challenge. I saw it on GoodGeek's channel. It's about making a game in 1 hour. So well, it's so tight time and I don't think I'll be able to do anything, but I wanted to at least try to do something. Basically, what I would like to do is to recreate some game which isn't that demanding to do. Maybe first I would try to implement only the basics and see how it will work, because making more in 1 hour is very difficult, and in the next hour I will try to create something else which I think will be the lookout of this game. So we're gonna add the characters I don't know, animations or just one picture. I think in Don't Touch the Spikes is the one picture, and yeah, we are going to create Don't Touch the Spikes. I found out this game to be really good for this challenge, probably because it has a simple mechanism which we can which is possible to make. And what is this mechanism about? Well, we're gonna play one game and I will show you what do I mean. So I'm gonna click a replay button, and there we have our character. It's a bird. The game will start when we click on the anywhere on this board. By the way, I'm using BlueStacks, so if you like to play it on your own, you just need to use it. Or you can download it from the Play Store on your phone. I don't know which option you prefer, but there, when I click it, the game starts. And what we just need to do is to bounce from the wall to wall, collect these candies, and avoid these triangles, which are the spikes. And every, I think, 10 points we get, the game speeds up. I don't know how many pixels per second, but yeah, it speeds up definitely. Later it becomes very difficult, and the color scheme is different every single speed up. I think, yeah, that's every single 10 points. All right, and we can click a replay button. Yep, and begin the game again. It's very simple, addicting game. Oh, and the number of spikes increases. As you can see, they spawn randomly on the board, on the left and right, band. Okay, that is gone. And what else? I think that's it. So the main problem we need to solve, I think, is the bouncing. Yeah. So bouncing itself seems to be just increasing some variable. So every let's say every cycle, which every time chunk we need to decrease the some variable, and the bird will like drop down when we add it. So it will be 5, 4, 3, 2, 1, and it will drop down finally. All right, and well, as this game is almost impossible to make in 1 hour, I just wanted to prepare with mathematical formulas at least. So there in this PNG photo, I've got 2 things that I pre-made off camera. So the first, and some of you may find it as cheating, but I don't think it's a cheating that much. We will need to implement it anyways, and I promise I've never tested it before. So the things that are written right here are just came out of my head, and I didn't check them anywhere. So basically what it is, there is that I divided this game into 2 sections. First is movement, and the second are spikes. I told you about the movement before. It's just decreasing some variable to the point it finally gets a negative, and when we add it to the actual position, the character will fall down. That's simple, and that's on the y-axis, and on the x-axis. There I wrote that was always the same tempo, but I wrote it some days ago, and I think when I played it after then, I found out it's not always the same tempo. It speeds up every 10 points, but we going to implement in this hour just this constant tempo because I don't know if we are able to do more. So that's the movement. And the spikes. Well, the spikes, so first what I needed to do was to calculate the hitboxes, obviously. What we'll need to do is to calculate the hitboxes, and as this and these hitboxes need to be precise, because we need to create the triangles, and they are sticking from the bottom, from the left, top, right. They are really the formulas need to be different. So for the left, so I just wrote down the formulas to the formula for the right-sided, so right-sided spike. It will stick up to the left border, and these are some of its points. So if our character intersects any of these points, the game will end up instantly. Yep. So the basic thing we're gonna do is to count these 3 points on the edges, but to test it, I think we will just count this this point on the top, because this one we need the most. Or maybe to test it, we just will look on the A point, because it's just the main point. I'll say the base point we calculate all of the other points from. As you can see, we are using its coordinates to the b coordinate. An example, we just add a edge, because these sides are the same, so we can label them as b, both as b. The point C is just the h position is x of this point plus h, and y coordinate is just y of this point plus a over 2. So I think it's quite simple. The other points D and E are just here because we want this spike to be like precise, because when we just live with these 3 points on the edges, if we will have this our character somewhere there, we won't die because this point don't exist. And when we create them, we are able to make it more accurate. Obviously, could try to set the points somewhere else too, but it's too much work and it's not worth it. And these D and E points are just the average of the distance, maybe not the distance, but of x and y coordinate of A and C points. That's the mathematical formula you may know from the school. And for the E point, it's the same. All right, and the other thing I did was to see how these points will change when we will like to rotate the triangle. So we basically always rotate this triangle about 90 degrees. So here we just rotated it about 90 degrees to the left. So right now, as you can see, if we have this spike positioned vertically, now just the things we added or subtracted from the x and y coordinates changed place. So if we have there a by 2 on the added to y coordinate, there we have it added to the x coordinate. The same with y coordinate. And what will happen when we just reflect it? I found out that only the coordinate, not the coordinate, but the sign will change. So instead of having there plus, here, wait a second, it's here. So on the x-axis, so here, instead of having here the plus sign, we got the minus, because it's logical. We just subtract the h from the x coordinate if the point is here. Okay, I hope that's clear. And there I found out I simply rewrote the intersection checking function from one of the previous episodes. we just check if the point is smaller or higher than y and x coordinates of the edges. And the third thing I have done was to change how to flip things horizontally, because I have never used it before, and I didn't know how to implement it. And right now I hope it works. It works in CSS because it's almost the same as in CSS. And I think that's all, basically. And the other thing I've done was to install the timer. So right now we are starting with the counter. I will set it up. I will start it when we start the challenge up. So basically, what I want to do before I start it is obviously to close the game itself, because we don't need it. We actually played it. So I close it. And maybe I will leave this picture on the second screen I have. So it's just full screen. Maybe I won't. Well, I wouldn't like to have it full screen, because I would like to see the stream statistics. I only see the chat, but I think it's okay. Is there something else I need to say? Oh, and we will end up the first part of the stream whenever I fix the last bug. So it doesn't matter that 1 hour passed by. I need to make this game show up on the preview without an error. Obviously, I won't exaggerate this, because I don't want it to forever create a random bug and try to solve it on the end of on that second hour when I will have everything done. No, I just want to make sure the thing I will finish with is at least playable. Okay, so before I start this counter, I just want to tell you about something else. So we're using obviously the React, as always. Maybe that's not obvious, because most of you, I think, would use the Unity or how was it called? Godot, yeah. But I use just the canvas to do it. I know it can be a bit more difficult, but I don't care. Basically, that's why I made this this PNG file. Okay, the thing I wanted to tell you was that you can just preview this thing right here whenever you type this link to the browser. So basically, I say it again every single stream, but yeah, there you can preview it, and you can preview the code by clicking this little button, and there the sandbox opens for you. Okay, so basically that's it. Let's create don't touch the spikes. I wonder when I will stop with the progress. Maybe it can be on the very beginning. It can be somewhere in the middle. I don't know. I hope somewhere in the middle, or even there will be no breakpoint, no breaks. Okay, so let's start it up. Wait a second. So I just start the counter. And start writing, yeah. All right. So let's go with it. 3, 2, 1, go. Again, go. All right, so we're gonna make a reference. I think it was create ref. Oh my god. So let's make it with a static position of maybe width of 400 and height of, it will be weird, I think, 400 by 600. I shouldn't think that much about it. And the reference is just here. So make reference, make. No? Oh, React. Okay, so we have the reference created. We can maybe style a bit. So just the body itself is blue. I don't care. And canvas is background color white. Okay, that looks good. So we need to start a rendering function. I know what I miss. Constant. We're doing try catch. cons canvas and ctx or even c. Canvas. What's wrong? Oh, let canvas canvas is equal to ref dot get get count to get context. I think I made it all right. So get context to D. So it's canvas is ref current. There we've got the C. Okay. And we rendering function start. So if okay, I know. That's weird what I've done. There we need to use effect. Use effect. We put it right here, and the rendering function catch an error and console log we got an error in main. We're doing the try condition, and after every loop we need to window request animation frame and put a rendering function inside. Okay, and hopefully oh my god, we've got 8 minutes on the clock. Rectangle. Alright, so it appeared. I'm proud of myself. Now let's go with character. So our character will have, let's say, 50 by 50 by 50 by 50. X and Y coordinates are obviously not important now. Oh, and I forgot to see okay, so we're clearing it up every single keyframe, and there it needs to go. So we basically implement delta, let delta ref delta, and some timer t1 is equal to 0, and here t1 is equal to 0, so we're gonna if delta is more, actually if delta d, so oh my god, it was time. So time is equal to delta minus brief delta, and delta is equal to brief delta. Delta is equal to delta. Okay, and t1 we're adding it to time over 100, and we can let's say if t1 is equal 0.05, more than, then t1 is equal to 0. And we're drawing here let player is equal to object, and we need x, y, h, and width. So, oh, I know. Help. Oh. Too much of some other languages. And player. So we specify the player object, and here the class player is equal. Oh my god. And it should be the constructor itself. I wonder how much I'm able to do in an hour. It's very difficult. Oh my god. With and half. Alright, so we've got the player class, and then the player object needs to be new player, and X and Y are window fif 50 by 50. Inner width, I think. Yeah, inner width. It's okay. So we've got it. The object dot wow, finally we've done it. Oh my gosh. Okay, so the next thing is that we needed to move, so every something we need to player object X player object.x. Not a number. All right. So still not a number. Don't say delta. This one should be all right. Time is equal to delta minus previous delta. Okay, let's go with this. If time, but we will need more than just one. So okay, I think I made somewhere a mistake. I don't know where. Okay, I think it needs to be this one. maybe about 3. Okay. And we need to move it back if we touch the wall. All right, so y subtractor is equal to 3. Okay, and if it's actually x subtractor, not y. Yeah, so the x subtractor all right, add x subtractor needs to be turned to the opposite one if player object x plus its width is more or equal than the canvas width, or player object x is smaller or equal than 0. Then we need to do is equal to minus this. Okay, and it's bouncing from wall to wall. Okay, now we need to make it go up and down. So we create the y subtractor is equal to, let's say 3, maybe 5. So every single time, oh, I forgot to make a word drop. Every single piece of time object we are adding to player object y this okay, it's falling down. Okay, so minus 5. It looks very good. So we're adding it, and every let's say yeah, we need the t2 variable. T2 is equal to 0, and here we're going to to make a delta, and whenever the T2 is over, I don't know, 1, maybe, no, 0.0, maybe 6, and then we're going to add 1 to the subtractor. Okay, and you can already see it's bouncing, but it's let's go maybe more. All right, and if because this shouldn't be less than some value, so and y subtractor is more than, let's say, 5, minus 5, no, because it's less than 5. Oh my gosh, no. It's not smooth. It should be less than 6 then. All right, so minus 10. Minus 5. Okay, minus 10 I think was good enough. And there maybe plus 10. From 10 to 10. No, maybe 8. I don't know really. Nine. No, 6. I don't know. But we need to, anyways, we need to add the listener, which will listen to our game. Listeners, and we're going to put a listener right here. So constantly listeners is equal okay, so we're actually gonna click it, window, add even listener, click, and the function which is going to fire up. So if the click, we want the y subtractor to be 10 again. I don't know if it will work. I can see some jumping, but it's very strong. Subtractor plus equal half, maybe, because it's too strong. Okay, I can see it somehow works. Maybe it shouldn't. Why subtractor? When it's 6, maybe when it's 8, because it's... Okay, I think it works. So now we need the spikes. Well, okay, I need to check if the points are intersecting. Intersecting is equal to some function. Yep. And to check if they are intersecting, we need the don't need the player's object. No, we don't need. It's a waste of time. We just need the point. So x and y. Let's say it's yp and xp. So x and y of the point. So from the picture I showed you, is just ye needs to be smaller. So yp needs to be smaller than ya. So just the player object y or yp is more than yd, yb actually is more than, I think it's logical. I don't know why I wrote it. Player object plus w and yp xp is less than player x, or xp is more than player object dot x plus player object dot height. Okay. And if it is, then we, I don't know, intersecting. Intersecting. Is it intersecting? True or false? If this, that means it's false. And otherwise, it's true. Okay. So we check if it's intersecting. Now we need the points. So we're gonna roll them. Basically, we want the triangles to be here. let's write, let's draw one triangle. So C dot line 2, and we're starting with 0. Oh my god, how it was this line 2. I forgot. It's line 2. Oh, move to first. Okay, move to let's say 0, 20. C line 2. Now 0, 40, let's say. Uh, 0, 40. Then maybe let's do it on 2. Okay, so it's very small. So maybe let's do a 80. Yeah, now it looks good. And the next line, C line 2, is from this point to on x-axis, let's say it's 40, and here it's in the middle, so it's 50. Okay, it looks good. 50-50. And C line 2 to 20. Okay, and there we've got our spike. So we need to create the next class, spike, and in the spike we want its x, y, height, and a. Actually, it should be separated with a semicolon. Constructor x, y, w, and h. Okay, so by having this and this, we want here to be calculated xa, xb, xc. I know each point needs to have separated class, but I don't have much time remaining, so let's do it like this. Oh my god, I'm making mistakes so badly. At least the movement works. Maybe for me, I think it's too big. This spike, but it doesn't matter. want the constructor to this xa is equal to x, this xb is equal to b, yeah, we don't have it, ya is equal to y, this y, oh, and it needs to be a spike right, and xb needs to be equal to x, and I need my my paper. It's x plus h. Next one is this yb is equal to y plus a over 2. Oh my god, a. This yc is equal to yc, xc is equal to it's x plus h. No, it's this one is x, this one is y plus a. This y c is equal to y plus a over 2. And for now it's okay. Now we need to draw. Let's see, begin path, C. Oh my god, we got 3 points, so we just need to move to xa, xb, this xa, this xb, this xa, this xb. In C# I could just write xa and xb, I know. Then we need to align to this xb, this yb, then line to this xc, this yc, and the last line to this xa, this ya. Is everything alright? I hope so. FAB? What's AB? YA. Okay. I think it's good. C stroke. So we're drawing it, but first so we need a First, we want the table of them. So I think there should be 7. Which one? It's very important because we need to know which one is this from the top. And the offset between the spikes. Oh my god, I have 10 minutes left. So we just yeah, offset, and the offset is just offset is equal to offset plus which one, and there needs to be this offset, and we're adding this thing to the x coordinates. What x? No, not y coordinates. Yeah, this offset needs to go here and here and here. Okay. So, which one? Let's say 7. No, this one is a bit tricky. We need to multiply these things, yeah, because there are many offsets, and we want to add what do we need to add? Offset plus times which one plus the height times which one, something like this. Yeah, and this is the best offset. We draw it and we intersected, and we need to check so we check intersected do 2. Let's make it 2, and no, it doesn't need to be 2 because it's intersected. Okay, so if it's intersecting, XA, YA, this, or intersecting XB and YB, or intersecting XC and YC. If some of them are intersecting, need to return true. We need to return. Oh, no, we cannot do that we need to do something like this. If actually we could. Oh, I don't want to think about it now. Return false. Okay, so basically we need to check if they're intersecting. So next array, let's make a static array. Spikes left are equal to the array of 2, 5, 7. Okay. And so when we are changing it, we need to make a for loop of spikes left. So spike left of spikes left, let okay. I think I will give myself 1 hour, half an hour more, because I want to end it up. Okay, oh my god, I opened the Firefox. Oh my god. LiveStreaming. Oh. Hi. Okay, half an hour more maybe. Because, yeah, you see. Spike left. So, we've got this it should be spikes right. Oh, it doesn't matter. It doesn't matter. Okay. Spike left. So we're looping and let new spikes be equal to some array, or maybe on the top we are going to make these spikes, and it's an array, empty array. Spike left. New spikes, we're pushing a new spike right. and this spike right. Okay, an hour passed by. As I said, I give myself an hour more to make this, but because right now we only have the character and the spike that I think it even makes an error. X. Alright, so we need the X, the Y. So let's make spike right. So X is 10, Y. No. Yeah, 10, 10. The A. I don't know how much I put. So let's do 30, 50, maybe. Which one is spike left, and the offset between is 5, so if new spikes 0, if the new spike 0 is on, then we are looping through them. Let of new spikes, and we're drawing it. New spikes, draw. Oh my god, it works. It works. Okay. All right. So at least this works. So it should be 0 here. Yeah, 0. Maybe 15. No, it's Y. I don't want the Y to be here. I want width and height. So the height, no, this is A. So A is 40. Okay, now it looks good. All right. So we need to, I'll put there next variable which is which which one exists. So direction. So if direction is equal to right, I think it needs to be like this, and if it's equal to right, we need to draw this. If direction is equal to left, we draw something different. So as I remember, we just switch y plus offset is the same. So xy there. No, it's minus. It's just minus. Under minus. Okay. Let's see if it works. So there we need to push right. I'm okay. And left. Does it work? No, it doesn't. Because no, y needs to be plus anyway. This one on the x-axis it will be different. There it needs to be minus, and canvas dot width minus a minus h. I think it's gonna work. Canvas width minus x, canvas width minus x. No, it's not. No, x is okay. Okay, I know. There only goes minus. I spent so much time on that because we want this to be canvas for test. I just want to test it. Canvas dot width minus 10 minus 0. No. X on the x-axis. This should be all right. Oh, I know, because there should be offset which doesn't exist. Yeah, now it exists. Okay, so if we got it, then nothing more left than and then switch the sides from left to right. So it's really easy, I think. Spike 0. So here if x subtractor is here, if x subtractor is more than maybe here, or no, here, is more than 0, and else right. And for right, we just want this thing. Okay, so we're pushing it, but first we need to oh my god. Okay, it leads us somewhere. I think these spikes are too long. So there should be 30 maybe. And whenever we hit, so if if we wait, game over is when, so for let new spike of new spikes, then if new spike dot intersected alert you lose. We want to check it works. It works so badly. Okay. I see. Oh my god, so what do I need to do now? I think I need to refresh this page. Okay, so we're starting over again. How are you? I'm making a game in 1 hour. Okay, so it opened again. And what next? We want this variable to cut the game or reset it at least. So let game over be equal to false. If this happens, we want it to be equal to true, and we want this game over so if it is game over, we don't actually want to render anything else. So I think we are going to game over then something, and else we render the game. Okay. And obviously we want the next. So if game over, we need to reset it. So basically we need to render the object itself, but the object needs to be in the middle this time. So layer object X stays in the middle is equal to canvas dot width over to layer object dot y canvas dot height over to okay. And we want to render these spikes. Not this one. Where did I render it? Here. Okay. So I want to draw. No, it's a player object. Why? I want these spikes to render. Oh, I know. To render them I need to call this. So this thing will render the spikes when I and say no, it should alert here. Alert game over. It's game over. Okay, and we want to render these spikes the random way. So to render them, wait, I need to see how to get a random int from a range, because I don't know how to do that. I always forget it in JavaScript. Script math random. Wow, impressive. But how to here? Okay. So we're gonna copy it here. Get random arbitrary. So to get a random thing, what's everything whenever we change where it is. Oh my god. Here. Spikes left. So x subtractor is less than 0. And x subtractor is less than 0. We also need to do some other things. So I'm going to actually here. I need to do it here. So for let int e is equal to 0, e is smaller than, let's say, 3, e plus plus int let, and we're going to subtract, check if the subtractor is smaller than 0, or else well, I think we don't need it. No, we don't need it. We just need it only if smaller than 3. We need to get random random spikes. So I shouldn't call it new spikes. New spikes is equal to, oh, here is, it's equal to nothing. Spikes left should be equal to nothing too. And here we're pushing some new values. So get random arbitrary. Get random arbitrary from 0 to 7. Well, it shouldn't be like this. And you should die when you fall down, basically. Okay, let's do... Oh no, I have an error. Let's do the last thing. So we need to fall down. When we get out of the screen, we need to die. So if here, if player object y, this is the last thing, player object y is more than canvas height or player object y is less than 0, game over is true. And alert game over. Maybe let's do the random 25. It's a bit buggy, but it doesn't matter. Okay, let's, I think it was X. Or maybe let's see if it actually works. Because there was some D. Oh yeah, here. Okay. Works. Well, it gets out of the screen, I mean the spikes, but Alt and F3. Okay, so I've made the game in a half and in a 1.5 an hour. It's a bit buggy, I know. But you can play it actually. Again, if you go to this link, you can play it with me. And there's the game over. Okay, so I'm gonna end up this stream now, and I will make the break, and I will and we will meet each other when I will maybe next 1.5 an hour. Take next 1.5 an hour to like make this game more beautiful and less buggy. Okay. All right. So I hope you enjoyed.